All right, so we are going to talk very briefly about absolute and local extreme values and the extreme value theorem. And so in the textbook here, we have that the absolute maximum on some interval must be bigger than all other outputs on that interval. So whatever f of c is, it must be bigger than all the other f of x values. Same is true for a minimum. It's an absolute minimum if it's the smallest value of all the other output values. Which leads us to the extreme value theorem, which says if you have a continuous function over a closed bounded interval from a to b, then you have to have an absolute max or an absolute min. So as long as you have, there's some examples down here, a continuous function, but the interval has to be closed, then you'll have a max and a min. So if you look at x cubed, just from negative infinity to infinity, no absolute max, no absolute min, because the interval is not closed. You might have an absolute max or absolute min on an interval, like here, I have an absolute max at x equals 0, but I'm not guaranteed an absolute min, and the extreme value theorem says that there must be both. It's also possible that you might have an absolute max and an absolute min that get hit infinitely many times, but that's not really guaranteed unless your function is cyclic, okay, like sine or cosine, that's going to happen. So that's a very particular example, if you will. Also, if you don't have continuity, then this theorem is not going to work. So you might have an absolute max value, but notice with that whole, you don't really actually have an absolute minimum value. Here's a perfect example of when you have a continuous function on a closed interval that you must have both an absolute min and an absolute max that occurs at those 1 points. However, if you don't have a continuous interval, you might have an absolute min, but there's going to be no absolute maximum. Or vice versa, if you were to look maybe on this other side here. That brings us to the last piece of information in this video, which is local maximums and minimums. All that is needed for a local maximum and minimum means that around that area, there's going to be that small value. Or around that area, there's going to be a big value. So if the function value is really close to there, you can create a little window, are all bigger than some value, then we say that's a local minimum. Sometimes we also call that a relative minimum. And as well as if you can take a little box and look, then that would be a local max. So let's look back at these examples and see if we can find a local max or a local min. This one right here, the absolute minimum would also be a local maximum or a local minimum, excuse me. However, the absolute maximum doesn't have two sides to it, so it can't be local. It almost kind of goes back to limits, that you have to have it on an interval around C, and it can't have an endpoint value, if you will. On this example here, these absolute max and mins would also all be local maximums and minimums. Here, this absolute max would also be a local or a relative maximum. However, this point right here, even though it's an absolute max, wouldn't be a relative or a local max because there isn't a function on this other side. So I don't know if the function comes in like that or the function comes in like this. I'm not sure of that, so I can't say that this absolute max is also a local maximum.